In this video, I will show you using the substitution method to solve system of linear equations. I am going to do 7 systems. The last 2 systems are special cases because one of them has no solution and the other one has many solutions. So for system of linear equation, here is how we write the system. We have a bracket, and then this is a 4x minus y equals to 9, and then the second equation is x minus 3y equals to 16. And then using substitution method, this is what I am going to do. So number 1, I am going to write the equation as, so by the way, before I start rewriting equation, this system has 2 linear equations and 2 variables, x and y. What I am trying to find is, I am trying to find x and y that fit into the system. So you have x equals to a number, y equals to a number, you plug it into the system. The first equation is true, the second equation is true. So number 1, we have 4x minus y equals to 9. Let's express y as a function of x, or as y in terms of x. That's what I should say, y in terms of x. So I am going to swap the position of y and 9. So that is a 4x minus 9 equals to y. And then now this is y in terms of x. I am going to substitute this y to the second equation. So the second equation becomes x minus 3 times y, which is 4x minus 9 equals to 16. So when you do this substitution, the second equation is in one variable. Now, before I start solving the second equation, I have to remind you that when you have one equation and there are 2 unknown or more than 2 unknowns, the equation cannot be solved. Every time we solve an equation, we can handle one variable only. If there are 2 variables, that cannot be solved. When you see one equation with 2 variables, there must be a second or third equations to make it a system. So you have to solve the entire system instead of one individual equation. So back to equation number 2, you distribute 3. So you have x minus 3 times 4, that is equals to 12. So that is 12x plus 27 equals to 16. So x minus 12, 1 minus 12 is negative 11, and then 16 minus 27, that is equals to negative 11. So x is equals to 1. And then after you get one of the variable, the other one is very easy. You can plug it into either one of the equations above. I've just plugged it into number 1. So you have 4 times 1 minus y equals to 9, and then 4 minus y equals to 9, then y is equals to negative 5. So y is equals to negative 5. And then how do I know this is right? So simple. All you have to do is plug in x equals to 1 and y equals to 5 to the system. So both equations will be satisfied. And then what does that mean? So what that means is, so for the first equation, do we agree that if you express that as y in terms of x, so this one is y equals to 4x minus 9. How about the other one? The other one, you have x minus 16 equals to 3y, and then you divide both sides by 3. So you have y equals to 1/3 x, and then minus 16 over 3. So now we have 2 equations, right? And then they are both have positive slope. So when you sketch the graph, you will get something like this. You will get one equations like that. So you will get one equations like that. I will just call this one the slope equals to 4, and then the other one is slope equals to 1/3. And then once again, you graph both linear equation in the same xy plane, and then there is an intersection. So the intersection, the coordinate is x equals to 1, so x comma y, so that is x equals to 1, y equals to negative 5. And then this is the point where the 2 linear equation intersect, so that is the solution of the system. Right, so one system is solved. Let's move on to the next system. The next system, I am going to label my equation. So this is equation 1, this is equation number 2. We have a system of 2 linear equation and 2 variables, x and y. So this one is very easy. The first equation is y equals to some x. The second equation is also y equals to some x. So you are going to set the first 2 equations equal. number 1 is equals to number 2, and then you have negative x plus 2 equals to 3x minus 6. They are both y equals to, right? So y is equals to itself, then you set the two equations equal, and then you solve for x. So you have negative x, and then minus 3x equals to negative 6 minus 2, and then this is a negative 4x, this is a negative 8, then x is equals to 2. So we have x equals to 2, and then after you got one solution, the other one is very easy. You can plug it into either number 1 or number 2. So y is equals to negative 2 plus 2, and then that is equals to 0. So y is equals to 0. And then this one, the first one, we have slope equals to negative 1, so the line is decreasing, right? And then the other one, slope is equals to 3, so the line is going up. So what that means is there is an intersection. They intersect at a point. At that point is x comma y. The coordinate is x equals to 2, y equals to 0. And that is the solution to the second system. All right, moving on to the next system. The next system, I'm going to fully utilize all the space. So I will just move this piece over here, and then I will write the next system. So the next system, let's pick a different color. How about this? We pick a blue. So the next system is, we have 2x minus 3y equals to 2. And then the second equation is 5x plus 4y equals to 51. All right, so this is equation 1, this is equation 2. Which one should I rewrite? I would like to rewrite equation number 1. So equation number 1, how about this? We have 2x equals to 2 plus 3y. And then what is x equals to? When you divide both sides by 2, you have 2 plus 3y divided by 2. So you have 2 divided by 2 plus 3 divided by 2, and then there is a y. So x is equals to 1 plus 3 over 2y. And then this is the first equation. And then I am going to plug in this x to the second equation right over here. So what is number 2 becomes? So number 2 becomes, let's move up. So we have 5, and then times x. X is 1 plus 3 over 2y, and then plus 4y equals to 51. And then now we solve for y. You distribute 5, so you have 5 plus 15 over 2. And then plus 4y equals to 51. Subtract 5 on both sides. 51 minus 5 is equals to 46. And then on the left hand side, you can do a common denominator. So 4 for a common denominator, that is just 8 over 2, right? And then 15 plus 8 is equals to 23. So you have 23 over 2y equals to 46. And then what is 46 equals to? I mean, what is y equals to? Y is equals to 46. And then you multiply the reciprocal, which is 2 over 23, and then that is equals to 4. So y is equals to 4. So y is equals to 4. You plug it into either equation. So let's plug it into number 1. You have 2 times 4 minus 3y equals to 2. So 2 times 4 is 8. 2 minus 8. Oh, you have y. I plug it into x. Okay. Let me step back. You have 2x minus 3 times 4 equals to 2. So 3 times 4 is 12. 2 plus 12 is 14. 14 divided by 2 is equals to 7. So x is equals to 7. So now that is my solution. Y equals to 4 and x equals to 7. And then what does that mean? This one, if you are lazy, you don't want to like put it like that. Y equals to mx plus b, the standard form, the linear equation. Y equals to mx plus b, where that one is called slope intercept form. Okay, slope intercept form. So you can see the slope equals to 1 and 3, and then the y-intercept 2, negative 6. So if you are too lazy, you don't want to go that way, it is fine. So let me just summarize what that means. You have two linear equations. So let's say one line goes like this, and then the other line goes like that. They intersect at one point, and then this point, the coordinate is the solution, which is x equals to 7, y is equals to 4. I don't care what the line looks like, the slope going up, going down, I don't really care. So all I need to know is there are two straight lines. Really don't care about what the slope is. They intersect at one point, and that point is the solution. So when you plug in x equals to 7 and y equals to 4, they satisfy both linear equations. All right, so that is number 3. And then moving on to number 4. So number 4, let's do some fraction. So number 4, I'm going to do number 4 right here. Let's do some fraction. 1 over 16x minus 3 over 4y equals to negative 1. And then the other one is 3 over 4x plus 5 over 2y equals to 11. And then this is my equation number 1. This is my equation number 2. Now, I see some fraction. Now, how many of you like dealing with fractions? Raise your hand. I'm sure that no one would like to deal with fraction, right? Because you don't want to deal with like the common denominator stuff. Okay, so I hate fractions as well. So there is a way to get rid of the fraction. So before we do that, allow me to give myself some space. Now, for the first equation, do we agree that if I multiply both sides by 16, that will get rid of the denominator? Multiply the left side by 16 and then the right side by 16. I didn't change the problem, I only changed the outlook of the equation. And then for the second equations, as long as I multiply both sides by 4, that is enough to get rid of the denominator. Okay, let's see what do I have for the first equation. Distribute the 16. You have x minus 16 divided by 4 is 4. 4 times 3 is 12. 16 times negative 1. That is the first equation. And then the second equation, 4 times 4 is 1. So you have 3x. 4 divided by 2. 4 times, did I say 4 times 4? 4 divided by 4. 4 divided by 2 is 2. 2 times 5 is 10. So plus 10y. And then 4 times 11 is equals to 44. So here is my system. I didn't change the problem. I only changed the outlook of the function. And then this is my equation number 1. This is my equation number 2. And then for equation number 1, I can rewrite that as x equals to, did I miss a y? Yep, I missed a y. So x is equals to negative 16 plus 12y. So that is my x. And then I am going to plug in the first equation to the second equation right here. And then what is the second equation then? Then the second equation is you have 3 times the first equation and then plus 10y equals to 44. Distribution. So negative 48 plus 36 plus 10y equals to 44. That, I want to make that look like a y. So erase this. Y and y equals to 44. All right, 36 times 10, 46. And then negative 44 plus 48, that is a 92. And then 92 divided by 46, that is equals to 2. So y is equals to 2. Okay, so now everything becomes super easy. All you have to do is you plug that into the first equation. So you have x minus 2 times 12 times 2 equals to negative 16. And then you have x equals to negative 16 plus 24, then that is 8. So x is equals to 8. And then what does that mean? We have two linear equations. To be honest, I don't really care about the slope. We have two straight lines. Let's just draw two random straight lines. Let's say one looks like this, one looks like that, once again and again. I don't really care about the slope. Okay, so all I need to know is these two straight lines has an intersection, and then this intersection has a coordinate x comma y equals to 8 comma 2. They intersect at 8 comma 2. That's all I need to know. I don't really care about the slope, the y-intercept. I don't care at all. Okay, all I care is there is a intersection, and that is the coordinate of the intersection. So this is another system. So let's move on to the next system. The next system, let's pick some other colors. The next system, let's pick, what do you pick the color? So it's 5 times x minus y equals to 25, and then 3 times x plus y equals to 6. Should I distribute 5 and 3? No. Divide both sides by 5. So what do you get? Divide both sides by 5. You have x minus y equals to 5 minus... here. I am copying stuff over from my notes. This is a negative 25. Negative 25 divided by 5 is negative 5. And then this is x plus y. 6 divided by 3 is 2. So here is my system. And then you rewrite one of them. Actually, you can do this. You don't have to rewrite one of them. We rewrite both. X equals to negative 5 plus y. And then this one is x equals to 2 minus y. So you have 2x, and then you set them equal. So this is number 1, this is number 2. We set number 1 equals to number 2 because they both start with an x. Negative 5 plus y equals to 2 minus y. And then you have negative 5 minus 2 equals to negative y minus y. And then this is negative 7 equals to negative 2y. So y is equals to 7 over 2. Y is equals to 7 over 2. Plug it into either one of them. Let's just plug it into the first one. So number 1, we have x equals to negative 5 plus 7 over 2. Okay, so that is negative 10 over 2 plus 7 over 2. Then you have negative 3 over 2. So x is equals to negative 3 over 2. That is the end of this paper. And what does that mean? That means is I'm going to squeeze that over here. I don't care what the line looks like. I have 2 lines, and then there is an intersection, and then the coordinate is negative 3 over 2, comma 7 over 2. Negative 3 over 2, comma 7 over 2. Once again, I don't care about the slope. I don't care about the y-intercept. All I need is I have a system of 2 linear equations. I have 2 lines. They intersect at that point. That's all I need to know. Okay. And then we have 2 problems left. The next one is a special case. The next system has no solution. Let's go take a look. So the next system, I have a system. This is a x minus 3y equals to 6. The second equation is 2x minus 6y equals to 5. Let's rewrite. So this one is x equals to 6 plus 3y. And then I am going to plug this in over here. Plug this x to there. So that becomes 2 times 6 plus 3y and then minus 6y equals to 5. Distribution. 12 plus 6y minus 6y. Okay, I see something strange. 6y minus 6y is gone, right? 6y minus 6y is gone. So we have 12 equals to 5. We have 12 equals to 5. Hey, is 12 equals to 5? No, right? So even though you subtract both sides by 12, then you have 0 equals to negative 7. No, this is false, right? So whenever you encounter a situation like that, the variable is completely gone. You have 2 constant, one on each side, and they don't equal to each other at all. So what does that mean? That means this system has no solutions. This system has no solutions. Okay, let's take another look. So number 1, we have x minus 3y equals to 6. And then when you divide both sides by, I'm going to swap 6 and 3y. So x minus 6 equals to positive 3y. When you divide both sides by 3, you have 1/3 x minus 2 equals to y. So what is the slope? The slope is equals to 1/3. Okay. How about number 2? Number 2 is 2x minus 6y equals to 5. I am going to put the y to the other side. So 2x minus 5 equals to 6y. Divide both sides by 6. You have 1/3 x minus 5 over 6 equals to y. So what is the slope? The slope is equals to 1/3. So what happened when you have 2 lines and they have the same slope? Then these 2 lines are parallel because they have identical slope. What is parallel? Parallel lines that looks like this. So this is one line, and then this is another line. So they are parallel. So there is no intersection. Therefore, this system has no solution. All right, and then the next case, which is the last system that I'm going to solve in this video, has many solutions. Let's go there. So we have another system. That system is y equals to x plus 1, and then 3y equals to 3x plus 3. Do we agree? That take a look at the first and the second equation. The second one, all I did was I multiplied both sides by 3. So this one is just y equals to x plus 1. And then the second equation, when you divide both sides by 3, you have y equals to x plus 1 as well. So basically, we have two identical equations. So this is number 1, this is number 2. When you let number 1 equals to number 2, you have x plus 1 equals to x plus 1, and then x minus x equals to 1 minus 1, 0 equals to 0. This is true. This is not false. What happened when you have no variable and you have constants only, and the left side is equal to the right hand side? That means this system has many solutions. This system has many solutions. Why? Because the first line, this is y equals to x plus 1. And then when you draw the second line is also y equals to x plus 1. So you have two overlapping lines. We call this two dependent equation. And then what do I mean by many solutions? So let's say x equals to 5, then you have y equals to 5 plus 1 equals to 6, then you have a 5 comma 6. So that means you just name your x. So every time you name your x, pick an x, you plug it into the first equation, you'll get a y. Whatever you have, x comma y, you can plug it into the second solution, the second equations. That works every single time. You can pick x equals to 0. Then y is equals to 0 plus 1 equals to 1. Then you have 0 comma 1. Plug this into the second equation. That will work for sure. As long as the point is on the line, then that point will work for both equations, because we have two equations. They are exactly the same. They just don't look the same, but they are exactly the same. So we don't have two lines that intersect at one point. We have two overlapping lines. All right, so that is the last system in this video. If you like the way I explain system of linear equation solving system of linear equation using the substitution method, give this video a like, give my channel a subscribe. I truly appreciate your help. As always, I will meet you all in the next video. Signing out.